Hello, welcome to the session on deep learning in NLP. So in this session, I'm going to explain few concepts and methodologies which are involved in application of deep learning techniques in NLP field. So as a general intuition, when we deal with the deep learning networks or the deep learning algorithms, the major criteria or the major focus is on the input to the network. So generally, a deep network or a deep neural network will involves an input involving numerical data, right? But in NLP applications, we generally use textual data. So the challenge or the major criteria here will be to convert the textual data which is available with us into the numerical form. So in this session, I am going to explain few such methodologies which are very much necessary to convert the textual data into the numerical form. The very first method or a technology which we are going to implement in converting the textual data into the numerical form is the creation of a occurrence matrix. First, let me just define what is the term occurrence matrix. The occurrence matrix is also referred as term occurrence context matrix, or it is simply called as occurrence matrix, where each row is a term and each column represent a occurrence context. So let's take an example of a matrix. So generally a matrix will consist of rows and columns, right? So the occurrence matrix will consist of a rows where each row will be representing a single term. A term refers to a word within a sentence, and the context refers to the sentence or a book or an entire document. It is completely dependent on the requirement. So occurrence matrix is also called as term document matrix, right? Since its rows and columns represent the terms and the documents or the occurrence context respectively. So the term document matrices are commonly used in a task where we are involving with the text or the information retrieval. So suppose if I want to search a document within a large corpus, or if you want to extract a similar document, like I have a document, I want to search a similar kind of document within a large corpus, then we are at the intuition to create a occurrence matrix. So why we are creating these matrices? Because to find the similarity between the document, like suppose say if you are given a document, as a human beings, what we do, we'll read the entire document, we'll understand the context of the document, then we try to search the similar kind of document in the available set of large corpus. But mathematically or statistically, what we can say, two documents or two vectors or two matrices are said to be similar if the angle or the cosine angle between the two matrices, that is the dot product of the matrices, is available with us. So hence we are trying to create this occurrence matrix so that we can compute the vector measure or the dot product of these vectors and find out the similarity between these document or occurrence matrices. So this is a classical example or a generic example of how a occurrence matrix will be looking like. So as I mentioned, it will be consisting of rows and columns where each column C1, C2, C3, etc. representing a context or the where that exact particular term is occurring. And the W1, W2, W3, that is rows, represent the words or different terms available in the given corpus. So here an example where W1 and C1. See, that word W1 is occurring in the C1 for one time, and the same word is occurring in the document or the column C4 two times. So this is a classical example how an occurrence matrix looks like. So see, I am available with the occurrence matrix. Now the major criteria comes with us is the knowing the weight of the word. See, the previous slides I have mentioned there will be a different terms and different frequencies. It is basically a frequency matrix, right? So I'm measuring a word. See, this say the given W1 word is occurring one time in the C1 and two times in the C4. Now, how do I decide the value of that word? The value of that word would be the weight of that word. There are different methods or different ways to know the weight of that particular term. Weight is nothing but how important that word is for us in terms of overall documents or overall text corpus. The very first thing is the distributional incidence. So distributional incidence is nothing but drawing a matrix similar to this. So by looking at this matrix, we can easily say that the word 4 is occurring 4 times in the document C2, which says that the word 2 in the document C2 is very much important, or the weight for that word 2 is high. This is one way of identifying, but this is a simple term. So it is a simple way of understanding, but you have to draw the entire matrix. Suppose I am taking just an example of 3 words. What if the context available with us is like, say, a big document with large number of lines and sentences? Then we can't keep on drawing this matrix, right? It will be very large. So then we will be going with another approach called distributional frequency. So distributional frequency is a improved version of distributional incidence. What we are doing here is we will be computationing the frequency of that word using a formula mentioned here. So here the frequency of the word or the frequency of the term is equals to 1 by 2 plus 1 by 2 into frequency of that given term divided by maximum frequency of that term in the entire text corpus or the entire set of documents. Suppose take, say, example cat. So I will take the frequency of that cat, how many times that cat is occurring in a given document. Then what I will do, I will search for that word cat in all the available documents. Suppose I have 4 documents, I will see the occurrence or the frequency of that word cat in all the 4 documents. Then I will compute the formula using this, and I am going to understand the weight of that word. So how important that word cat is for me. And the last and the best method, or the the most computationally advanced method, that is finding the TF-IDF value. I think most of them will be aware about this because it will be covered in the previous sessions, where it is to define the term frequency or inverse document frequency. By that also we can able to get the weight of the given word in a given occurrence matrix. So I will explain this with one more example to understand it better. So the example of the occurrence matrix is the table which I am going to show it here. I will take some documents, or say a paragraph written on different topics. So those paragraphs I am going to list it as a columns. See, that is what the context is, right? So I'm going to take movie names or a movie review written on 4 different movies. One, Harry Potter and the Sorcerers of Stone, then The Prestige, Wolf of Wall Street, then Hangover. So all these are the 4 different movies. So each movie will be containing certain reviews. So I have picked some 5 words where I am going to see the weight or the create the occurrence matrix here. So I have taken the word fear and I found that it is occurring 10 times in the Harry Potter and the Sorcerers of Stone. See, as a general intuition you can say that that word fear may be most frequently occurring in the movie, right? That Harry Potter. It is basically a wizard or a kind of magical movie, right? So there it is very common to see that word fear. And when compared to the same thing in the Hangover, that Hangover movie is basically some chilling kind of movie, right? So in that movie we are very much least concerned, or we cannot even find that word fear in the Hangover movie review. This is a classical example which I am going to show you. So this is how you can understand an occurrence matrix looking like. In the further session, I will be going to explain the demerits or the side effects, or what are all the challenges that can be faced while creating the occurrence matrix. Thank you.